We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hi students, this is Professor Gaurang Patel from Mahatma Gandhi Institute of Technical Education and Research Center, NAVSARI. Welcome back to my lecture of digital control and its applications. Okay, in last 2 lectures we learned about how to convert that analog signal into the digital signal and how can we feed those data into the computer system. Okay, now in this lecture we are discuss regarding the Z transform. Okay, Z transform play a very important role in digital control and its applications. Okay, so we will see it step by step how the Z transform is work, some of the basics of the Z transform, and how it is applicable to the digital control system. Okay, then now before switch over to the Z transform, what we are doing, we just take some glimpse of Fourier transform as well as the Laplace transform. Okay, so here I will show you some of the equation of Fourier transform and some of the equation of the Laplace transform, how it works. Okay, then we will just go to the next slide. Over here we can see some of the introductory part of the Laplace transform as well as the Fourier transform. So first of all, over here in this box you can see, okay, you can see this part. Okay, this is the part of sine Fourier series, we can say that. So it shows that Fourier transform works with the sinusoidal signal. Okay, so in detail we can say that Fourier transform tells us frequency or sinusoidal remain present in the signal. Okay, and when we talk about the Laplace transform gives us the information about the sinusoidal as well as the exponential signal remains in the function. How it will be work, we can see with some of the equations. Okay, well, we can also say in another terms, that is Fourier transform is the slice of the Laplace transform. Okay, now I will show you. These are some of the things, if you want to write it down in your notebook, that what I already explained to you, that is Fourier transforms tells us frequency or sinusoidal remain present in the signal, and the next one, that is the Laplace transforms, tells us exponential as well as sinusoidal remains in the signal or function. Okay, so how it will form, we will see over here. Just a minute. Okay, so when we worked with a signal, suppose we will take one of the signal, that is x of t. Okay, this is our input information or input signal, that is x of t. Now what we are interested to find out, we are find out the Fourier transform of that particular signal. So for that, what we have to do, we have to integrate whole the signal from minus infinity to infinity, and it will be multiplied with exponential of minus j omega t dt. Okay, this process will give us the transformation of just a minute, transformation into x omega, that is the Fourier transform. We can consider this equation as the basic Fourier equation, where x of t, that is we consider as an input, and x of omega, that is we consider as our output. Okay, so I hope you understand how this equation comes into the picture. I will just show you in another slide the same thing, that is the equation of Fourier transform as we discussed, that is which is the input part, that is the x of t, that is the input part, and that is x of omega, that is the output of that particular signal which we had taken. Okay, so here we can see input x of t. Here input x of t is function of time, obviously we can see it, and output is a function of x omega. Okay, so which tells you the which sinusoidal is present in your signal. Okay, understand what I want to say? Okay, so in next slide we can see how it will be work, that will going to be give you a better understanding. Okay, so this is the equation of Fourier transform, what we already seen. Okay, so what it suggests that if you put pure cosine curve, that is your pure cosine curve as input, okay, that is your input, if you put pure cosine curve as your input, then your output is one spike of the cosine curve. Okay, that is your output, you can see that is the one spike of your cosine curve. So that means you can see how the Fourier transform simplifies that particular signal that we want to investigate. Okay, okay, I hope you understand what is the Fourier transform and how it will be work. Now we will move towards the Z transform. Before move towards it, we just have some overview regarding those statements. That is input x of t, that is the function of time, and output x of omega, that is the function of omega. And next one, that is if you put pure cosine curve as input, then output is one spike of the cosine curve, that what I explained to you already. Okay, now what we are interested to move towards the Z transform. Okay, so I will just write that down over here, that is Z transform. Okay, so basically what is transform do? Okay, it will convert the time domain signal into the frequency domain signal. It is very important statement. Okay, Z transform does the time domain signal into the frequency domain signal, or it will convert the time domain to the frequency domain. The next term, that is Z transform, is applicable to discrete time system only. Okay, it is applicable to the discrete time system only, that is known as DTS as well. Okay, so now when we are talking about the discrete time system, then Laplace transform as well as the continuous Fourier transform comes into the picture. Okay, because when you move from CTFT, that is a continuous Fourier transform, to the Laplace transform, that you must have to know about the j omega, that is the real part and imaginary part as well. Okay, so when you go from CTFT to LT, that means when you move CTFT, that is your j omega, to the LT, at that time sigma plus j omega comes into the picture. So we can say that when we move from continuous Fourier transform or CTFT to Laplace transform, we will get from j omega to the sigma plus j omega. We will just understand in a better way. I will show you how it will be work. Okay, now we will see this in the detail. Okay, that what I try to make you understand, that is we are working on the Z transform, that is the Z transform. Okay, so basically what it does, it works or it's applicable only to the discrete time system. Okay, now when Z transform comes about the same way as CTFT, that is the continuous Fourier transform, and in which variable is omega. Okay, in CTFT the variable is omega, in generalized to the Laplace transform. Okay, now when CTFT generalized to the Laplace transform by going to j omega to sigma plus j omega, we can see over here when we generalize CTF to CTFT, sorry, into the Laplace transform, our j omega is generalized to sigma plus j omega. That means what? That is, we introduce the real part sigma over here. It is very important to understand. Okay, over here we introduce the real part of the signal, that in form of sigma, and that is how we going from j omega, that is from the Fourier transform, to the Laplace transform, that is in S domain, or we can see that is a Laplace transform. Generally we consider it is comes into the S domain. Okay, so what does it do? Okay, the question is, what does it do? It do the enlarges the capability of Z transform, okay, to handle the wider class of signal or system. Okay, what it will be do, it will enlarges the capability of Z transform to handle the wider class of signal or system. So when you control with the Laplace transform or Fourier transform, you have just the limitation over that signal. Okay, but in Z transform you can wider your limitations. Okay, so this was the basic motivation for going to CTFT to LT, that is continuous Fourier transform, to the Laplace transform. Okay, so these are some of the basic that we must have to know when we move towards the Z transform. Okay, so we just have some of the idea regarding the Fourier transform as well as the Laplace transform. Okay, these are some of the statements we can see. That's what I already explained to you, that is Z transform applicable to discrete time system only, and ZTransform enlarges capabilities to handle the wider class of signaler system. Then next we will see one by one the properties of ZTransform and how it will work. We will also see the ROC, that is the region of convergence, in the ZTransform, okay, in the next lecture. Okay, thank you.